All right, guys, we're back hard at it. I think this is video number 7, maybe. As you can see, I'm out at the boatyard today. I'm here in my garage, so that's good news because that means we're actually building stuff now instead of sanding and taking stuff apart. So in this video, if you're going to be watching me make a bunch of measurements, I'll talk about that in a little bit. But like I said, we're starting to put stuff back together. So what I've got here in front of me is a piece of, this is actually garage door insulation, but it's representative of what I'm going to use to actually put back in the boat to build the boat back, which is this product here. This is a scrap piece that I had laying around. It's called Kusa. This particular style, I guess, or variety that I'm using is blue water 26-pound density, 3/4 inch Kusa. It comes in a standard 4x8 sheet, just like plywood would. And that's pretty much what I'm going to be using to build the boat back. Everything will be exclusively made out of this material. I think it's a polypropylene fiberglass reinforced material. That said, this is pretty much the go-to standard for boat builders these days for the most part, unless you're building something like a high-end race boat or a big 60-foot sport fisher. It's not quite economical to build it out of this yet, so they still use either newer technologies like carbon fiber, or they do it the old school way using marine grade plywood. The reason I'm not going back with marine grade plywood is this is about 20 to 30% lighter than marine grade plywood, so it's a huge weight savings, which when you're a shallow water running boat like I am, the more weight you can keep out of the boat, obviously the better the performance is going to be, the less water you're going to draw. Also, this stuff is virtually rot, what's the word I'm looking for here? Rot independent, rot exclusive. It won't rot. It'll pretty much last forever because it's a polypropylene fiberglass material. So it doesn't rot. It doesn't absorb moisture. I think moisture absorption for Kusa is rated at something like 1%. So it's effectively 0. And it'll basically last forever. It's super, super strong. You work it just like you would work it with plywood. Same tools that you would use to cut or shape plywood, you can use to cut or shape Kusa. It takes resin better than plywood does. So resin is the glue that you use to fiberglass with. It takes resin better, and it uses less resin overall as part of the fiberglassing process. That said, this stuff is very expensive. Well, I guess maybe if that's relative, but for me it's very expensive. So what I have before you is, like I said, a sheet of everyday garage door insulation. So it's a 4x8 sheet, 3/4 inches thick, just like the Kusa I'm going to be using to build the boat back with. You can pick this up at Lowe's for like 15, 20 bucks, something like that. So the idea being is I've made all my measurements off of the boat, and now I'm going to transcribe those measurements onto this sheet to make a template. This overall sheet right here costs about 5% of what one sheet of Kusa costs. So if I screw this up, it doesn't really cost me anything. I can just throw it away, go buy another sheet, start over. I could theoretically do that with Kusa, but the cost is much, much higher. So it's a lot easier for me to get it right on this step than it is to try and do it on a piece of Kusa. Once I have my template made out of this and it fits nice in the boat and I'm happy with it, I'll take that template, transcribe it into the Kusa, cut it out of the sheet of Kusa, and that'll get glassed in the boat. That's kind of the process. That's I'm doing an intermediate step here. This step's not necessary. If you're more confident in your measurements or a better woodworker than I am, you probably wouldn't do this step, but I put the me in amateur, so that's why I'm doing this step, because I don't really know what I'm doing and I don't trust my measurements. So and I'll talk about what I did for measurements shortly, but anyway, I'm going to use this as a template to make sure it fits, like I said, because I can afford to screw this up a bunch of times if necessarily. Hopefully I don't. Hopefully I get it right out the gate, but I can afford to screw this up I really can't afford to screw up a lot of sheets of Coosa. So anyway, that's what I'll be using. As anything going through this process, I've learned a lot. All the guys in the boat yard have been super friendly and happy to come over and help me and give me tips. In fact, I've gotten so many tips, it cost me about a week worth of time because I got myself confused. But there is actually a better material than this to even use to template with that costs about the same amount of money, but it's a little bit easier to work with. I don't know if you can tell in the video, but this is pretty flimsy. So I'm going to have to be careful not to break it as I'm making my templates. But going forward, the guys in the boat yard showed me a better material to template out of, so I'll probably use that. And it's around the same price point. Yeah, so anyway, let's get started. Like I said, what you're going to see me do is I'm going to make marks down the length of the sheet here, and then I got my measurements here. I'm going to transcribe these measurements based on those marks onto the sheet and then cut it out. Basically, this will be the exact same process that I'll do with a piece of Coosa. Like I said, only it won't cost me as much if I screw up. So yeah, enjoy watching me transcribe and make the template. And I'm hoping to get 2 templates out of this, maybe 3 if I'm lucky. I'm not sure if I'm gonna have enough material. I only bought 1 sheet of this because I wasn't sure. My initial thought was to just do 1 template, 1 stringer, and see if my measurements were close. And if they were, I may go ahead and jump right straight to the Coosa, because like I said, this is an intermediate step and it is taking time, which, you know, luckily I don't have a hard deadline that I have to meet, but I don't want to take more time than I really need to either. Since, you know, I'm only I only have Saturdays and Sundays now to do this, so I have to use my time wisely. Anyway, I'm hoping to cut 2 stringers, so I'm going to do my center stringer, which is the biggest of the 3, and then either the port or the starboard, depending. So, and if I can squeak all 3 out of this sheet, then I'll try and do that, but again, we're going to play it by ear. Alright, well, I'm going to get started.
Okay, ladies and gentlemen, I want to take a little bit of time and explain how I got the measurements that will eventually translate over to the new stringers that are going in the boat. So you have my crude rectangular shape here that's going to represent our boat. So we got our bow, and we got our stern, and then these outer lines here and here are the true sides of the boat, and then these 3 inner lines are what will be representing our 3 stringers that we're trying to put back in the boat. It's kind of the starting point of the rebuild process, if you will. And so the true bottom of the boat that these stringers reside on. So let me back up first. The stringers connect what I'm going to call the top deck, the deck that you walk and stand on, to the true bottom of the boat. It also connects the stern of the boat back here. You know, this line representing the stern to the bow of the boat here. It helps to stiffen the whole shape of the boat up. Without those stringers being in there, the boat is like a big mold of jello, and it flexes and twists and as you move around. So if you were to run the boat in the water without these stringers in place, effectively what would happen is the stresses of the boat moving through the water would be enough to crack the boat in half. So, very important structural piece of the boat here. So what I did to get the measurements for these 3 stringers was I set the height of where I want my new deck to be down the sides of each boat, down the sides of the boat, excuse me. And then I made a mark every 6 inches at that height down each side. So 6, 12, 18, 24, etc. Did that for both sides. Okay, then I took a straight edge, ran it across the width of the interior of the boat from each of those points. So 6 to 6, 12 to 12, 18 to 18, 24 to 24. As you can see, we end up with all these intersection points here. You know, there's 1 there, 2, 3, 4, etc. What I did, these are what I call my touch points. So each one of these intersections, I took my tape measure and I ran it down and got the height or the depth of from the bottom of the straight edge, which is represented by the red line, to the true bottom of the boat, which is represented by the black stringer line here. And that gave me the depth. And so I did that down the full length of the boat for each of the stringers, and that gave me kind of a contour, a height contour, if you will, of how tall or short the stringer needed to be at any one of these given points as we progress down the length of the boat. From that, I'm able to generate a pattern, and then I just take those measurements and scribe them onto the sheet of Kusa, and that gives me the general shape of the stringer to cut out.
dia a dia hadir amin on the track, yo.
As I was saying, at each one of those touch points, I made a measurement. So as you can see in my nice Excel file here, I took those measurements on 3 different occasions. As I mentioned earlier, the boat without this checkerboard stringer set up in place is all loosey-goosey. So at least for the port and starboard stringers, I made those measurements outside of the boat. Just based on the width of the overall boat, it's pretty much impossible to get the center stringer measurements without physically getting in the boat. But for the port and starboard ones, I did make those measurements from the outside of the boat, so my weight didn't affect the overall contour of the floor as I was taking the measurements. So again, took those measurements 3 times. Basically because I don't trust my own measurement taking abilities, and then averaged them together to give me an average height for the full length of the boat. So this gave me my stringer profile, if you will. So as you can see here, here's pretty much my height. I was pretty happy overall with my measurements. For the most part, I ended up about 1/8 of an inch or so within all 3 measurements, which I was fairly happy with, except for up here in the bow, there's a little bit more play, and that's just based off of me trying to take a measurement on a descending curve. It was a little tricky to do, and I expected there to be a little bit of a slop. It's still tighter than honestly what I thought it would come out to be, so I was pretty happy. And I think by taking the measurement on 3 different occasions and averaging it, it's going to get me pretty close. So did that for all 3. So here you see the port, there's the center, and then there's the starboard stringer. And then what you're able to do is once you have that average measurement, I created a set of plot points here. So basically it's the same thing. I just inverted them, made them negative, so it makes the plot look a little more logical. And so doing that, you're able to plot them. And then this gives you the overall contour shape of your stringer, and this is the shape that I would expect to see. So you can kind of look down here. This is effectively the true bottom of the boat, with your 0 x-axis up here being the deck that you would walk on, and then obviously the space in between would be the height of the stringer. So you can see the right-hand side would represent the stern of the boat, left-hand side would represent the bow of the boat. So as you move from the stern towards the bow, that average height gets narrower and narrower until eventually the true bottom of the boat and the floor that you're walking on effectively touch. And that's what we see here. This was very good. This is generally the shape that I was looking for. And the reason I did this was, like, if we go here and we look at the center plot, if I have a bad measurement or something wonky is going on with the floor, it will show up in this plot. So like right here on my center stringer, you see this measurement here, kind of common sense tells us would probably really should be somewhere down in this general area, but yet it spikes up right there. So that could tell you two things. One, this was either a bad measurement value, or I happen to know that because I went back and checked it, this measurement value, there's actually a fair amount of fiberglass resin build up in the stringer track in the boat, which has created a high spot. And so that's what's showing up here in these measurements is that high spot. So, logically it gave me a point to go back and look at, and which is what I did, and said, oh yeah, look, right there in the boat, there's a high spot. I can see the resin build up. Okay, this is tracking. It makes sense. Same thing back here in the stern of the boat. You can kind of see we're true flat through the center section of the boat, and then the stern kind of starts to rise up a little bit. And that's okay. We expect that, so that actually holds true to the shape of the boat, if you will. So she is a little higher in the bow and the stern than she is through her midsection. So again, this all makes logical sense. Overall, I was pretty happy. Didn't see anything abnormal that really jumped out at me that I didn't expect to see. So that's why I proceeded on, and we're going to go take these measurements, transfer them onto the sheet of foam I talked about earlier, and cut some templates out that'll be representative of the real stringers that will eventually be cutting out of Coosa. Again, want to do the foam templates first, because if I screwed something up or something doesn't fit right or whatever, it's cheap, throw it away, start over. Whereas the Coosa is not cheap, and I really can't afford to throw it away and start over. So I can afford to make some mistakes with the foam. I know even doing this method, once I get them in the boat, I'm going to have to do some sanding and maybe some build up to get everything to sit kind of flush, if you will. And so I'm going to fine tune that with the foam. And so once I transfer what is the final product of the foam stringer over to the Coosa, it should be that much less work in the end for the final product. Fiberglass work in boat building is really all about prep. When you go to actually put your final product in place, there should be almost very little work to be done, because you have to do so much prep leading up to it. And that's kind of what you see here. One last item that I do want to mention for the center stringer here, I did add a 1/4 of an inch to whatever the measured height was, and that's to give me a little bit of crown in the floor. So the floor is kind of going to be a little bit like a mountain, with the center stringer sitting about a 1/4 inch higher than the starboard or the port stringer. 1/4 of an inch, you may or may not be able to see it with your eye, not sure, but the main purpose of that is so that when there's water in the boat, it'll roll off either to her port or starboard side. So it just gives a little bit of slope to the floor to help it shed water towards the stern of the boat.